Okay, the question reads as follows. We have a negative charge that's distributed uniformly. No, I think we took the wrong picture. That's not the question I was trying to do, but anyways. I remember what the question is. So the question reads as follows. We have a small sphere with mass m carrying a positive charge q. So we're gonna have to show you the So let's go ahead and show you how that looks like. Let's try without that now, yeah? So the sphere is of mass m, carries a positive charge q, attached to one end of a silk fiber of length L. The other end of the fiber is attached to a large vertical insulating sheet that has a positive charge density sigma. Show that when the sphere is in equilibrium, the fiber makes an angle equal to arctan. So we need to prove that theta is equal to inverse tan q sigma. Let's make that a legible sigma here. Divided by 2 mg epsilon naught. Okay, so let's go ahead and make a small free body diagram of the image here. So let's say this is the sheet, charge sigma, and this is the sphere, and this here is angle theta. And let's go ahead and the sphere has a charge of q, positive q, and this here is L, this here is positive q, and let's go ahead and do the free body diagram on the sheet. So we have the weight mg, we have the tension, and due to the vertical sheet of charge density sigma, of course we have an electric force that's going to push the sphere to the right, and we will call this Fe. So these are the forces on the sphere. Conditions for equilibrium. Summation of forces in the x has to equal 0. Summation of forces in the y has to equal 0 because the sphere is not moving neither in the x nor in the y direction. And by the way, let's call x to be positive and to the right, and y to be positive and up. So of course the tension, which is the tension in the cable, can be resolved into two components. One, two, and this would be t cosine theta, and this would be t sine theta. And so the sum of the forces in the x would be so this is 1 and this is 2. So we know that the electric force minus t sine theta has to equal 0, and we know that the electric force is nothing but sigma E. and we know that E, I meant to say 2A, not QE, and we know that E for an infinite plane sheet is sigma over 2 epsilon. Putting this here and this here, we will get Q times sigma over 2 epsilon naught minus T sine theta is equal to 0, which makes T sine theta is equal Q sigma over 2 epsilon naught. So that's equation number 3. And now we will go ahead and work out the summation of forces in the y equals 0. So we know that T cosine theta minus mg equals 0, which means T cosine theta equals mg. So this is equation 4. And we will say equation 3 divided by equation 4 and we will get equation 3 divided by equation 4. We will get the t's will cancel out, so we'll get T sine theta over T cosine theta as Q sigma over 2 epsilon naught divided by mg. The t's go away. Sine over cosine is tan theta equals Q epsilon over Q sigma over 2 mg epsilon, and if we take inverse tan, we get theta to be inverse tan Q sigma over 2 mg epsilon, which is the desired result and what's required to prove in this question. Hope you enjoyed it. Thank you.